Writing a chemical equation. Converting an English sentence describing a reaction into a chemical equation. A chemical equation is a much shorter way of presenting the information about a chemical reaction than a sentence in English describing the reaction. It can provide additional information as well that is not immediately obvious in the English sentence. As an example, take this very well-known reaction. Hydrogen gas reacts with oxygen gas to make liquid water and release energy. This becomes 2H2 gas plus O2 gas, arrow 2H2O liquid plus energy. I want to point out several things that appear in the balanced equation but are not present in the English sentence. First, the formula of hydrogen gas is H2, and the formula for oxygen gas is O2. The names of the elements are in the sentence, and if we remember which elements are diatomic, that is a relatively easy connection. We also have the formula for water. Most of us know the formula for water from middle school or earlier, but the formula is not immediately apparent from the name. There are many compounds for which this is true. Having the formula in the equation allows us to see the law of conservation of mass in action. Finally, in the balanced equation we have the coefficients, which tell us the relative amounts of each substance that are involved in the reaction. Note that, since there is no number before the formula for oxygen, we assume that the coefficient is 1. We will deal with balancing equations later in this chapter. Each of the other things in the reaction, the states of the substances and the energy, are explicitly given in the sentence. So, how do we go about writing the equation for our reaction? Let's write the skeleton equation for the reaction. Chromium-3 carbonate solid reacts with a hydrogen nitrate solution to form a chromium-3 nitrate solution, carbon dioxide gas, and liquid water, and to release energy. Probably the first thing we need to do is to write the formulas of the substances in the reaction. This is something we have already learned how to do. We know how to find the formula from the name for an ionic compound. So we know that chromium-3 carbonate is Cr2 parentheses CO3 close parentheses 3, because chromium-3 is Cr3 plus and carbonate is CO3 2 minus. We know that hydrogen nitrate is HNO3, because the hydrogen ion is H plus and nitrate is NO3 minus. And chromium-3 nitrate is Cr parentheses NO3 close parentheses 3, because chromium-3 is 3 plus and nitrate is NO3 minus. We also know how to write the formulas for molecular substances. So we know that carbon dioxide is CO2, because the prefix di means 2, and water is H2O. Energy is not a substance, so we will deal with that later. Now that we have the formulas of the substances, what is next? Next, we need to determine for each substance whether it is a reactant or product. To determine this, we need to go back to the sentence. We look for the verbs to identify whether a substance is reacting or is produced. There are 2 verbs in this sentence. The first is reacts with, and the second, to form. The divider here is to form, and this sentence is written in a way that the first things are the reactants. The verb reacts with shows this, and the 3 substances after to form are all products. So, chromium-3 carbonate and hydrogen nitrate are reactants. Chromium-3 nitrate, carbon dioxide, and water are products. Now we need to write the skeleton reaction. The formulas of the reactants are written on the left. Then comes the arrow, which always points to the right. Then, on the right of the arrow, the products. The order in which the reactants are written does not matter, as long as they are on the left of the arrow. Similarly, the order in which the products are written does not matter, as long as they are written on the right of the arrow. If the information is given in the sentence, then we should add symbols which indicate what the state of each particular substance is. There are four main state symbols. Solid is S, liquid is L, gas is G, in solution, or aqueous, AQ. Aqueous means in water. The symbol is added in parentheses after the formula of the substance. So, the state symbol for the chromium-3 carbonate is S. For the hydrogen nitrate, it is AQ. For the chromium-3 nitrate, it is also AQ. For the CO2, it is G. And for the water, it is L. If energy is mentioned in the sentence describing the reaction, it can be added to the reaction as well, although it is not essential. You need to read the sentence carefully to determine whether energy is added to the reactants to get the reaction to occur. Phrases like is heated or energy is absorbed are common if energy needs to be added, or if energy is given off when the reaction happens. Phrases like energy is released or producing heat are common if energy is given off. If energy needs to be added to get the reaction to occur, then the energy goes with the reactants. And if energy is given off when the reaction happens, then it goes with the products. In this case, to release energy tells us that the energy is given off. So we put plus energy with the products. One of the interesting and in some ways difficult things about English is that we can completely change the order of a sentence to change the emphasis of the sentence without fundamentally changing the meaning of what we are writing. This can create confusion in writing chemical equations unless you read the statement carefully. For example, here is the same chemical reaction with all the same information but written differently. Energy is released and a chromium-3 nitrate solution forms when chromium-3 carbonate solid reacts with a hydrogen nitrate solution. Carbon dioxide gas and liquid water are also produced. Note that the same substances are still present, but they are in a different order in this statement. The first two things mentioned in this statement are energy and chromium-3 nitrate. Carefully reading the statement shows clearly that the chromium-3 nitrate is a product and that the energy is given off. It is also clear that the chromium-3 carbonate and hydrogen nitrate are the reactants. So a careful reading of the statement gives us exactly the same list of reactants and products. This list is in the order of the substances in the statement. Here is another different way of writing the statement of the reaction in English. Again, a careful reading of the statement gives us the same list, this one in the order in which things are written in this statement. One other quick note here. If the mixture heats up, but we are not heating it, that means that the reaction was giving off energy.